Now we're going to look at how to identify a linear function from a nonlinear function. We've already talked about how functions are used to model real-world phenomena like distance, weather, energy, and the economy. And here we're going to focus on a linear function. A linear function we can write f of x equals mx plus b. And if we're graphing this, b is where we begin on the y-axis. And m is how we move off of that axis. So here we have a function, f of x equals ax plus b. We're really just replacing the m for the slope with an a. It doesn't really matter what letter we use there to represent slope. The big thing about a linear function is that the exponent on the variable is 1. A nonlinear polynomial or nonlinear function will have a variable not to the first power, to some other power. It could have the variable under radicals. It could have the variables in the denominators. So here we've got some questions. Are they linear functions? If so, can you identify the slope and the y-intercept? So we have f of x equals 3/4 x minus 11. I see that I have a constant times my variable, and then another constant. 3/4 is my slope, and negative 11 is my y-intercept. This is linear. How about g, cube root of x, plus 9? Well, that cube root with the x does not look anything like our standard form for our linear function, ax plus b. We've got another operation in there, a cube root. This is not linear. And then for function h of x equals 6.5 plus 7.9x. Is it linear or no? Well, I have a variable here, x, and a number times x. And then I have another number added on. 7.9 is my slope, 6.5 is my y-intercept. This is linear. With our y-intercept in the first one, sorry for jumping back there for a second, in that y-intercept, we want to keep that negative sign, negative 11, for the y-intercept. That negative sign is important. And then how about this last one? F of x equals 5 divided by x. Well, this really looks nothing like our linear function. Dividing by x means we have a rational function, not a linear. And since it's rational, it's not linear. Let's look at linear functions as tables. Here we have values for x along the top, and f of x is supposed to go in the bottom row. Remember that f of x is the same thing as y, and that we can take this f of x and replace it with the variable y. So now we're evaluating the function at these different values of x. If we start at 0, 5 times 0 plus 3 will give us 3. For 1, 5 times 1 plus 3 is 8. For 2, 5 times 2 plus 3 is 13. And 5 times 3 plus 3 is 18. This gives us a set of ordered pairs that we can then graph. I'm sorry I didn't give you a lot of room on this. I'm going to cheat a bit and come over to the side here and draw my graph larger. What's important about the graph is that we have equal spacing for these tick marks. And then starting out 0, 3, 1, 8, 2, 13, and 3, 18. This is a pretty steep line. 3 is where I begin on the x-axis. So remember this equation is 5x plus 3, and 5 is how I move. Notice I'm going up 1, 2, 3, 4, 5, and over 1. And so I can recreate that graph also by using the function. Try this next one on your own and see if you can get a graph. Let's see if we can determine if we have a linear function. Here's a table. Do I have a linear function from it? Well, let's break down our table for a second. What I want you to notice in the table is how I go from one number to the next in the x row, and then also in the f of x row. In the x row, to get from 0 to 1, I would add 1. To get from 1 to 2, I add 1. And to get from 2 to 3, I add 1. For the f of x row, which is also y, to get from 1 to negative 1, this is the same as subtracting 2. Negative 1 to negative 3 if I subtract 2. And negative 3 to negative 5 if I subtract 2. Since each one of these rows is lending to a constant change, this is going to be linear. My run in the x direction is 1. My rise in the y direction is negative 2. So if I calculate my slope, I get negative 2. And then to determine the actual function for this linear function, when x is 0, y is 1. So this is my y-intercept. 1 is my y-intercept. I can create my function, slope times x plus b. And I'm getting this from my y-intercept here, and then my slope by looking at the change in the table. So let's go through the next table. Let's see if it's a linear function. We'll start out like before. How do I go from 0 to 3, 3 to 6, from 6 to 9? We add 3 each time. But how do I go from 8 to 4, 4 to 2, and 2 to 1? 8 to 4 would mean I subtract 4. 4 to 2 means I'm subtracting 2. 2 to 1 means I'm subtracting 1. I do not have the same change. So this is a nonlinear function in this case.